All right. So I wanted to actually start this morning with the feedback from the survey, and thank you so much for answering these. There were actually more people that answered it than are people in the class. So some of you are very motivated to get those bonus points, but still, I think there's enough unique people, unique students to answer it to let me know some useful stuff. And the stuff that's on the screen up here were things that multiple people mentioned. There was also something else that one person mentioned, and it was something like, don't stare at individual students so long, and I like totally do that. So whoever said that, thank you, I'm really gonna try. And I know who I do stare at the most. It tends to be people who are looking at me, so thank you for that. I'm gonna try to do better and try to look way far in the back, because I know I don't look at you all enough. So I'm actually going to start from here about lab exams. This has been a common request over the years, like, can we do lab exams like AMP1, where you have 4 of them and they're more spread out? That is an option. Like, I can't change it this semester. It's an option, but if I did that, we wouldn't have the open lab days. So that's why I do it that way. I would rather have the open lab days for like a big review chunk and then have 2 lab exams. So there's trade-offs to that, but that's why I do it that way. The second thing that several people mentioned is that when I give you the review sheets before an exam and it's got the 7 major topics, I'll get.
Volleyball team needs it on Teams.
What?
The volleyball team's trying to get it on Teams.
Thank you. I didn't know that they were going to try to join. That's awesome. Hey, volleyball team, I hope you don't get sick watching this in the van or the bus. About some of the stuff on the exam is not on the review sheet. And I went back and checked these first 2 exams, like how much of the points actually did come from what's on the review sheet, and it's about 75%. But I know sometimes there are things that are on the exam as a short answer that weren't on the review sheet. That's going to happen, but I try to keep it a quarter of the exam or less. So I always want to hear about that, though, if you feel like exam questions are unfair. I care very much about that. The next comment that I get every semester is slow down. And I would like to, but I also have to make sure that we get through all of the body systems. So I feel you there. But I also got to get through all the body systems. This one, some people mentioned that they would rather have the blanks filled in on the slides. And I have those, and I can make those available. And I think I will after today. But just don't get like lulled into like, oh, I don't have to write anything. I can fall asleep. I don't have to pay attention. So now that we've gone through half a semester with blanks, I think I'll post the ones with blanks if you like them, and the ones with the blanks filled in if that would be better for you. Just don't fall asleep. I don't think you will. I don't think you will the rest of the semester. And then this suggestion was kind of a combo from several people of, could there be different tutoring times and review times for exam? And could there be more open lab times? Open lab, we're so restricted with COVID stuff right now that I probably can't do a lot more with open lab times, because there has to be somebody to be able to be in there, and there has to be no class meeting in there. So open lab times for the second lab will probably be about like they were for the first one. As well as, it's real important to come to the actual scheduled open lab day if you can. But for review and tutor times, if the tutor times and the review times don't work for you, and if you let me know a little bit ahead of time, like not the day before, but I'm able to do review times when I'm here. So for this next exam, if probably the next exam review is going to be on Sunday, March. Thank you. 14th at 7 p.m. That will be the normal exam review time. If you know, say by like next Wednesday, that you can't make that time for a real specific reason, let me know and I can set up a different review time with me. And if you would like to just come and see me for tutor stuff, anytime I have office hours or I'm not in class, I can do that. And I get way better as a teacher when I'm with people one-on-one and I see, oh, okay, this is not making sense, and I'll make a new way to explain it. And that really helps me. So if the tutor times aren't working out for you, let me know and I can schedule other times. Presley's about to be in, she started her season, so I'm not gonna put more, like, hey, can you do more nights? But I can, so just let me know. Thank you all so much for answering this. This is always, it's kind of like ripping off a Band-Aid, like, but a lot of this stuff, people say it the same every semester, so it gets better over the years, and it makes us all better teachers when you all do the feedback surveys. Okay, so we have a few extra things that we need to finish up from the last slide set. And it's about the pancreas. I don't know if pancreas appears on both lab exams because it's both endocrine and exocrine. So the endocrine part has to do with the pancreas making hormones, glucagon and insulin. The exocrine part has to do with the digestive enzymes. Your pancreas is little and squishy and blobby and unimpressive looking, but it's one of your more important organs in your whole body because it does both of these things. When you're looking for it on the torso models, find the beginning of the small intestine. So this is small intestine here. This is the end of the stomach. And the pancreas is kind of nestled into this curve of the small intestine. That's where you'll find it. It's kind of behind your stomach, kind of stomach's here, pancreas here, and the small intestine curves around it. So your pancreas has two kinds of cells, and each type of cell is doing one of those roles. We'll see the microscope slide again for it on Tuesday. And most of the pancreas is these dark purple cells, and then here and there, you've got these lighter regions called pancreatic islets. Pancreatic islets, like islands. And those are making hormones. There's alpha and beta cells that make hormones. Both beta cells and alpha cells are in the islets. The beta cells make insulin, which is going to lower your blood sugar. The alpha cells make glucagon, which has the opposite effect. It raises your blood sugar. And the other thing that these hormones do is they're going to move they're going to affect glycogen in different ways. So we can make this storage form of carbohydrate glycogen. This marker is 2-yen. And we keep glycogen in the liver and in our skeletal muscles. Insulin helps us build glycogen or put glucose into storage. Glucagon, let me change how I'm writing this. Glucagon this needs to be more obvious for people who aren't here right now. Insulin helps us build glycogen from extra glucose. Glucagon does the opposite. It helps us break down glycogen so that we put glucose into the blood. This part is going to happen after meals, after we eat. So we supply glucose to our body cells, and if we've got extra, we'll build it into glycogen. But then between meals, or if we are fasting, not eating on purpose for some reason, glucagon will be produced from the pancreas, and it will break down glycogen to then move glucose into the blood. And especially, we need the glucose to go into our brain. We can't store glucose in our brain. It doesn't have the physiology to do that. So we keep it in the liver, and we keep it in our skeletal muscles. And then if we go for a while without eating, we can make glucagon to move glucose out of storage and keep fueling our brain. Our female wrestlers aren't here today because they're on the way to championships, and a lot of times they have to cut weight and not eat on purpose. And that makes it hard to think and do well in classes. But somehow they still do. They do well in classes. But I've always hurt for them inside that they have to go through that. So that's the endocrine part of your pancreas. The exocrine part is the digestive enzymes production. And that's done by most of the cells in the pancreas that are these dark purple. They're called acinar cells. And they're making pancreatic juice. Pancreatic juice is the combo of all of the different secretions that are digestive, and those come out of the pancreas. So there are 5 digestive enzymes that your pancreas makes. Those are in pancreatic juice. And the other part of pancreatic juice is bicarbonate. Bicarbonate. And the bicarbonate is going to neutralize the pH of stomach contents. Remember, you make all this acid in your stomach, and what's in your stomach is super acidic. I'm going to go backward a few slides here. Okay. So here's your stomach, and it's got gastric juice and acid helping digest, and then the food contents are going to leave your stomach and come by the small intestine. And as they pass by here, they're going to pick up from the pancreas the digestive enzymes and the bicarbonate. So see this little blow up box right here? There's a tube coming out of your pancreas that's carrying all that digestive stuff. And this is the pancreatic duct with a T. So out of this duct is going to come pancreatic juices with their enzymes and their bicarbonate, and that's going to balance out the pH of all that acidity coming out of the stomach.
Make it more basic, or just...
It is going to make it more basic, but it's moving it toward neutral pH. Does that make sense? Like, the bicarbonate is basic, and it's going to combine with the acid, and it's still overall kind of acidic,
Okay.
but less acidic. It's a good question. Okay, so there's alkaline contribution from the bicarbonate, and then we have 5 different pancreatic enzymes. 5 different pancreatic enzymes. And these would be, in our list of 13, this is number 4 out of all the 13. This is number 5. And these 3 are 6, 7, 8 in the big list. And this set, these are 3 individual ones here. These are 3 separate enzymes. The first one is an amylase, which is a starch breaker. Amylase is breaking down your complex carbs into disaccharides, a double sugar. It's like salivary amylase, except it's coming out of your pancreas. So one of your pancreatic enzymes is for carbs. The second one is to break down lipids, and it's a lipase, pancreatic lipase. It's splitting lipids, kind of like gastric lipase in the stomach, but this is the pancreatic version of that. So that's your lipid breaker. And then we have these 3, which have these annoying names: trypsin, chymotrypsin, carboxypeptidase. So all of these 3 are starting to break down proteins. Together, they start to break down proteins, but they don't get all the way to amino acids. They halfway break down proteins. Some people do not have good pancreatic exocrine function. There's this radio commercial that I'm old and I listen to the radio actually. This radio commercial that comes on every so often, and it's saying like, do you think that you have pancreatic insufficiency? You should talk to your doctor, blah, 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 blah. If people don't have good pancreatic exocrine function, they will need to supplement with digestive enzymes. They will need to take digestive enzymes kind of as pills with their food. And there are different groups of people with different diseases that have to do that to break down their food if their pancreas isn't working well. So all of those pancreatic juices are going to come out of the pancreas through this pancreatic duct, which is in the yellow here. and drain out into this region that looks like a little heart right here. Boop, heart. That's called hepato for liver. Hepato-pancreatic ampulla. Ampulla is a word that means cup. So you've got this little cup-shaped structure here where you've got pancreatic juice coming this way. And then you've got bile, or bile if you're from around here. Here comes the bile coming down from the gallbladder and the liver in this green structure here. And so by their powers combined, you've got a lot of digestive power coming into the small intestine here. You're getting a big dump of bile, which we'll talk about in a minute, plus all the pancreatic juices coming into small intestine at this hepatopancreatic ampulla region. That's one of the structures on your lab guide, which means you need to get close with the spelling. Get close, you can do it. If you start now, you can do it. Oh, somebody also said it would be good to get the quiz questions, and sometimes I forget that, but these are the quiz questions from 2 days ago, or close to it. The green thing is a bolus. Enzymes do the chemical digestion, and that one I had made it into a multiple choice, I think. So I will try to remember to do better about getting the quiz questions to you all, quiz answers. Okay, now we're switching on to the slides that are supposed to be for today. And they're called liver and intestines. Specialty meats. Oh, okay. This should be close to the quiz questions for today. Out of these, bile is made in the liver. This is from the small intestine. And then I made up some other new question, and now I don't know what it was. Do you remember?
Something about like what's on the small intestine.
What's on the small intestine?
Yeah, it's like villi.
Villi or microvilli?
It's like which one of these?
And then there's like a lymphoma.
Okay, which one of these are in the small intestine? I think it was all of the above. Does that seem right?
No.
No?
One answer. It was which one of these isn't.
Isn't. I don't
I
know.
think it was the lobule. Yeah.
Lobule? Okay, yeah, lobules. Lobules are not in the small intestine. I used to give the quizzes in class and like hand out papers every day, and you could write down an answer. So when I convert them to Canvas, if I've got things like this, I've got to either make a new question or make it multiple choice. So sometimes I haven't written down what I actually put. Okay. This is a lobule right here, and it's part of the liver. And your liver is one of your biggest internal organs. I mean, it is your biggest internal organ that's in your torso. It's pretty big, pretty heavy. And when we look at it under the microscope on Tuesday, the subunits of it are called lobules, and they look like hexagons. It's really weird in your body if you ever have straight lines around the edge of something, but in the liver you do. So if you see a tissue and it's got straight lines around the edges of the parts, that's the liver. They're mostly hexagonal, but that's the key to identifying it on the slide. Your liver is really big and it's really important, and it does an incredible number of jobs for you. And your liver lobules do an amazing amount of chemical reactions in your body. Your liver can do some amazing chemistry to turn certain kinds of nutrients into certain other kinds. Your liver also stores important items in your body. And then its third big function is that it makes bile. It makes this chemical called bile. We're going to go through next. Your liver has 7 functions, but they all fall into these 3 groups. They all fall into these 3 major groups of what your liver is doing. There we go. So the first 3 functions are nutrient conversions of the 3 macros. And there's a lot of words up here. So write the blue stuff first, and then I'll talk about what that means. Okay, so first one, carbohydrate nutrient conversions. Your liver can turn carbs into other kinds of carbs. That's what I mean by that arrow there. It can turn glucose into glycogen, so build sugar into a complex carb. It can break down glycogen and turn it back into glucose. And your liver can also do something called gluconeogenesis. Gluconeogenesis, so sugar, new, build. And that's when you take lipids and turn them into carbs, or you take proteins and convert them into carbs, like from a new macro. That's gluconeogenesis. Your liver also turns proteins into other kind of proteins, or breaks down proteins, builds up proteins. So when I'm drawing this arrow that comes back around to proteins, that's an interconversion, like you taking proteins and making new kinds. Your liver does that too. Your liver can do lipid interconversions. Can build lipids into new kinds of lipids. It can also take carbs and make lipids out of them. It also can take proteins and make lipids out of them. I feel like this diagram is getting very confusing. But that's what I wanted to show. Yeah, go ahead.
And that can be made back into a protein from carbs.
Yes, this is kind of going back to some stuff that was in that video lecture last Friday. So at the end of each section, there was this liver, and then it had all these arrows coming out, and like what it can do. You can interconvert any of the macros amongst each other, except you can't make a protein from the other two. So I'm going to kind of say that concept again slowly. You can turn carbs into lipids. You can turn proteins into lipids. You can turn lipids into carbs. You can build proteins into lipids or carbs, but protein, you have to eat it. You can't go on a no protein diet. You can go on a fat-free diet and you can build fat out of the other two macros. You can go on a super low carb diet or keto and you'll build carbs out of the protein and the fat that you eat. But if you don't eat protein, you can't make protein out of your other body structures.
You can't synthesize it yourself.
You can't synthesize it yourself. Like, you gotta eat it. If people actually don't eat protein, like if you break down your muscles, so like, certain kids, like they don't want to eat any meat. They can get by with that for a while. You should try to give them peanut butter or something so won't break down their own muscles. The other time, usually if people are protein deficient, it's because they're so poor they can't afford protein. They'll break down their muscles to supply the essentials for their body, but then when they really run out and they've got no backup supply, they will start to be in really poor health because of that. So your first three liver, not the same thing. Your first three liver functions are converting the macros in different ways. You need to memorize these liver functions, but it's not like you need to memorize this whole mess right here. Just know it's carbohydrate nutrient conversions, protein nutrient conversions, lipid nutrient conversions. So those are the first three liver functions. This is another picture of a lobule under the microscope. See how it's got straight looking edges, straight lines? So the fourth function of your liver is that it stores all of this essential stuff for you. It stores iron, stores vitamins. So if you're one of those few people that eat liver and enjoy it, it's a great source of vitamins. And it stores blood, kind of in a backup way. So there's a lot of blood in your liver. And if your blood volume drops real low and you start bleeding out, all the blood will come out of your liver to try to help you. It's pretty cool. It's a blood reservoir. Number 5 is another chemistry thing. Number 5 is a chemistry process. Your liver can convert chemically different drugs, toxins, and harmful chemicals. So if you overdo it with alcohol, your liver is going to chemically change the alcohol into something safer for you. Same for medicines, drugs, as long as you don't overwhelm your liver and wear it out, work it to death. Don't do that. It detoxifies. There's all these like diets and fads and stuff right now. Like, you can do this detox cleanse if you do these 5 things, or if you drink this juice or whatever. Your liver detoxes you. That's a fact. Like, you don't need to detox yourself if your liver is healthy. And your liver will be pretty healthy as long as you eat well and don't take a lot of drugs and alcohol. Your liver detoxes you. Your liver maintains your blood health. This kind of fits into chemistry the best. Your liver maintains your blood health. So it filters your blood somewhat, and it will take old red blood cells kind of out of circulation, and it recycles their hemoglobin. Hemoglobin's real valuable. It's got iron in the middle of it, so we don't just get rid of it. Your liver will take the hemoglobin and recycle it into these two pigments. And these are green. They have a greenish color to them. Bilirubin and biliverdin. Right underneath here, greenish yellow, those pigments. And then these pigments, once they're produced, they actually go into BIOL, which is function 7. But if your liver is not working well and these pigments don't get put into bile and don't get processed correctly, that condition is called jaundice. How do you know if somebody has jaundice? Their skin is going to be a yellowish looking color. And maybe they're the whites of their eyes. So in people who have normally more dark skin, it's harder to tell, is that jaundice or is that just you? So our first, sorry to tell you all this story. Our first son was born in Seattle, and there's a lot of Asian people in Seattle. So doctors there are used to seeing kids that are Asian or half Asian. And then our second two boys were born in Arkansas, and there are very few Asian people in Arkansas comparatively. So our second son, Moses, when he was born, there was this young doctor that came in, and he was checking Moses out, and he's like, he looks a little bit yellow. I think he might have jaundice. I said, well, his dad is Asian, so maybe he does have jaundice. And Moses, he is a little bit, like, slightly more yellowish skin tone, but he didn't have jaundice. It just has an Asian parent. So I always would rather have a doctor that's like 60. They've seen everything. The boy's doctor now is so older. I'm always thinking he's going to retire, but he's seen everything. He can diagnose in an instant. Dr. Pancreas, if you all grew up around here, he's great. So function 7, your liver is supposed to make bile partly out of those pigments. And then it's supposed to store the bile in the gallbladder. So this little green sac peeking out here is the gallbladder. And I need to make a note here about bile. You need bile to break up or emulsify fats during digestion. I think we got a picture of that coming up, but I wanted to write it here. If your liver is not making bile for you, or if it's not appropriately coming out of your gallbladder, you cannot, well, you can push through and eat a lot of fat, but you'll regret it. You won't break down fat, you will poop out all the fat that you eat, and it's unpleasant. Any of you had your gallbladder taken out? Do you have to watch what you eat?
No.
Well, good. I'm so glad. You might later in life, or maybe you don't eat a lot of fatty stuff anyway. But normally, if you have your gallbladder taken out, you can eat some fat, but you don't have booster backup bile storage to help you if you eat a lot of fat at once, and it might cause you gastrointestinal disturbance. So this here is a cartoon of what bile kind of chemically does. It's an emulsifier. And what it does is a bunch of bile molecules will get around a lipid and they will let it dissolve into smaller drops. I need the word up in this number. It's breaking up fat into smaller drops. So if you eat a lot of fat and you've got a large lipid droplet going through your digestive tract, bile will help it break up into small droplets. And these are going to be easier to digest. Bile is kind of in between a mechanical and a chemical digestion. It's not really changing what the lipid is, it's just making it into smaller pieces and getting it to disperse. Because this won't dissolve in water. And you're a watery being, so you need bile to help break up those droplets and help digest your fats. So bile, it's got salts, the pigments, cholesterol. So remember we said your HDL cholesterol, your liver is going to send it out of your body. It's sending it out of your body in bile. It's got some electrolytes in it. It's chemically kind of destructive if it gets outside of your digestive system. And if your bile gets too concentrated, it will form these crystals that we call gallstones. So this is an X-ray of somebody that has gallstones, and they're totally filling up their gallbladder right here. And that level would call for removal. That's kind of an emergency situation. And then the rest of their time, they will make bile and store it in the liver a little bit, but you don't have the backup bile storage in the gallbladder if it's gone. You can have gallstones less seriously than this. If you just have a few, they tend to clog up your bile duct where it drains down into the intestine, and then it hurts, and it's upper right quadrant pain for gallstones. So this question about symptoms of liver disease. There are a lot of ways to get liver disease. You can have liver cancer, you can have cirrhosis because of alcoholism. People that survive a serious drug overdose sometimes will have liver disease. But these are the symptoms that are caused. Jaundice, being tired, too much blood ammonia, edema, and pale feces. One of the things that we're going to go over on review day is how these symptoms come from the 7 functions. And you might want to look over this ahead of time and see if you can match up. Oh, if you lose this function, it's causing this symptom. So if you lose the function of the liver, it's going to affect all of these different 7 roles. And if those 7 functions are messed up, they lead to these symptoms. There'll be a question on the next exam, how does the loss of the functions lead to these symptoms? And we'll be going over that on review day, which is next Friday. But I want to go on now and talk about small intestine. It would be, the best would be if I could get through small intestine before the end of the day. This video, I'll show it on review day. So your pancreas and your liver are accessory organs. They're not part of the tube. They're not part of alimentary canal. So when we put food in our mouth and chew it, and it goes down the esophagus, into the stomach, starts coming through the small intestine, that junction region between stomach and small intestine, that's where bile is coming in, and that's where pancreatic juice is coming in. But what they're coming into is the beginning of the small intestine. The small intestine is where you're absorbing nutrients. It's really the main part of your digestive system that can absorb those small nutrient molecules and move it out of your gut and into the blood. And as we're going through this, I want you to be thinking about that question of how is the structure of the small intestine related to good absorption. Small intestine has a lot of cool anatomy that allows absorption. In a living person, there's this membrane covering the intestines called greater omentum, and it somewhat holds them in place because you don't have any bones here. So your intestines are held in a little bit by that greater omentum and then your abdominal muscles, but no bones to support them. It's a vulnerable place on the body. Your small intestine is really long. If you were to stretch it all the way out, it's, think about it, some number of feet long. And it kind of coils and twists around in your abdominal cavity. And it's divided into 3 regions. It's kind of like beginning, middle, end. So the beginning region is called duodenum. Duodenum. And the duodenum is right after the stomach. So kind of this is the dividing point between stomach and small intestine. And that first part, that's where the pancreas and the bile duct would be putting in their enzymes in the duodenum. The end of it is next to the large intestine, or the colon. So the part that is right at the end and it's connected to the large intestine, that's called ileum. Ileum. And then the rest in the middle is jejunum. So it goes duodenum, jejunum, ileum. When we label these in lab, we're like very obvious about where we put the sticker. So if the sticker is close to the stomach, it's going to be duodenum. If the sticker is right next to large intestine, it's ileum. And then if it's in the middle somewhere, that's the jejunum. Those are the 3 regions. So now we're kind of diving into the interior lining of the intestine. So we see that there's this finger-like structure called villus. If you're talking about one of these, it's called villus or intestinal villus. And these extensions are all over the interior lining of your intestine. Together you call them intestinal villi. So it's several different cells in the epithelium forming this finger-like structure, and up through the middle of it are capillaries. So each one has a capillary network running up through it, as well as a lymphatic vessel. This specific version of lymphatic vessel is called a lacteal. And the villus has a bunch of individual cells. So if you have, this is the lining of your intestine. Oh, it's fun. These villi create a ton of surface area. The villi increase surface area so that you can have nutrient absorption. So if the lining of your intestine was straight across, that surface area might be 10 square centimeters. And this might be 100 square centimeters because it's so convoluted. And what has to happen is you've got food residues out here with nutrients, and you've got blood supply inside there, and you're trying to get the absorbable units to go from the gut into the blood supply. So the more surface you've got to do that, the better you can absorb your nutrition. That's villi. The second structure that helps with this, it's the same concept, but it's smaller, called microvilli. Microvilli. And the microvilli are on the edge of individual cells. Still finger-like, but they're coming off the surface of one cell. So if we were to, this is a villus. Microvilli are like that little. I know you can't see that in the back. And they're doing the same kind of thing, just at a whole other level. Increasing the surface area. So when you add in the microvilli, maybe you have 10,000 centimeters square of surface area to absorb nutrients. So it's like that dumb song. There's a flea on a bump, on a frog, on a log, in a hole at the bottom of the sea. Like you keep going down and there's like a smaller thing on a smaller thing. Tiny, tinier, tinier. That's like the relationship between microvilli and villi. So if you've got this picture, draw some teeny pencil marks coming out of one of those that represents microvilli. They're on these individual cells. And then this will be the last slide for today. So now we're zooming out. So this is the inside of the intestine. And if you look microscopically, it's got microvilli and villi, and the whole entire lining is folded too. So the folds in the lining itself, those are called plicae circularis. The inner lining is folded. So here's the folds, there's the villi, and you could draw tiny little pencil marks coming off there to represent microvilli. The plicae circularis also increase surface area. Probably times 10. So whatever you would have if there were no plicae circulares. Plicae circulares would increase surface area 10 or 20 times more. I'm trying to write it's times 10 or 20 there. I think on Monday, we're actually going to do, I think Monday is actually going to be catch-up review. Wednesday we have off. Friday is going to be the group activity. I'm going to change that order a little bit because I'm behind. And I want to make sure I get all the major info to you all before you start studying for the exam, which is the second Monday. So this coming Monday, I'm going to finish these slides and also do some exam review and overview. Wednesday we have off. Friday will be the group activity.
I scheduled a meeting to meet with you about my exam. Can we do that here, or do you need to do that?
Yeah, we can. Probably out in the lobby out there.
Okay.